This is maybe one of my favorite math lessons that I like to go over in the classroom because it really puts together a lot of topics that you've learned. For example, you've done fraction to decimal and decimal to fraction conversion since probably fourth grade, um, and you've done algebra in sometimes seventh grade, definitely eighth, ninth, and 11th grade. But you usually don't put those two things together to tackle something like this, converting a repeating decimal to a fraction. You often just don't go over this when you're converting in an elementary or a middle school class because it requires a little bit of thought, a little bit of a cool little trick. So for example, let's say I want to convert 0.7 repeating into a fraction. Well, here's the trick. I'll just go through it slowly with this one, and then we'll do a few more examples, and then you'll understand the trick as we go. What I do is I say x is equal to 0.7 repeating. Let's set x equal to 0.7 repeating. And then, and here's the trick part, if we multiply that by 10, both sides by 10, this brings us back to Algebra 1. Multiplying both sides of an equation by the same thing is totally fine. We get 10x, I'll do it on top. We get 10x equals, well, what happens when I multiply a decimal by 10? We have 0.777 going on forever. And if I multiply that by 10, I'm just moving the decimal point over one place. So if I multiply that by 10, I'm going to end up with 7.777 going on forever. It's going on forever. Forever minus 1 is still forever. So we still have infinitely many sevens, infinitely many sevens. And now here's the trick. Here's the cool part. What I'm going to do is I'm going to subtract these from each other. This is another thing that you learn when you're learning systems of equations in an algebra course. We can subtract two equations from each other. And we get 10x minus x is 9x. And we get 9x is equal to, well, 7 minus 0 is 7. Point. This 7 minus that 7 is 0. This 7 minus that 7 is 0. And it goes on forever. We get 7.0 repeating, or just 7. You see that it all goes away. All of we cancel out the infinite part. And now if I divide by 9, I get x equals 7/9. And x was equal to 0.7 repeating. So x is equal to 7/9, which is equal to 0.7 repeating. And we see that we have successfully done our conversion. We had to use the world of algebra to do our conversion here. And this is the trick. This is the only trick. You'll see it doesn't get much different. We all should know what 0.3 repeating is going to be. You've converted that quite a few times and seen both of its versions. 0.3 repeating is just 1/3. So let's make sure that I'm telling the truth. Let's see if our method gets us to 1/3. So I'll erase the 1/3, pretend we don't know that, and let's get going. We have this time x is equal to 0.3 repeating. X is equal to 0.3 repeating. And 10x is equal to, what's 10x equal to? 3.3 repeating. Because we just move that 1 3 over. If you imagine the infinitely long number of 3's, this is what we had before, going on forever. Multiplying by 10 just moves that decimal point one place and gives us 10x equals 3.3 repeating. Subtracting down, we get 9x equals 3 point infinitely many zeros, or just a 3. And now if I divide both sides by 9, I get x equals 1/3. Sorry, I divide both sides by 9. I should explain that step. Divide both sides by 9 and I get x equals 3/9. But we all know that we can simplify fractions. Dividing the top and bottom by 3, I get 1/3. So we have x equals 0.3 repeating, x equals 1/3. So we have 0.3 repeating equals 1/3. And you might say, well, a decimal is not always that pretty. For example, 1/6, we know that this is equal to 1/6, or half of 1/3, is equal to 0.1 with the 6 repeating. It looks like this in an expanded form, 0.16666. And you might say, well, what happens there? Because multiplying by 10 isn't going to do anything. Well, we just multiply up until we have our infinite part accounted for. So instead of multiplying by 10 this time, I'm going to move 2 decimal points. I'm going to multiply by 100. So let's try it. I have, and remember, we don't know this yet. We're hoping it's that, but we don't know it yet. I have x equals 0.16 repeating. I'll multiply by 100 this time because I need that. I can't just multiply by 10. It might throw things off. I'll multiply by 100, and I will get 100x equals 16.6 repeating. 16.6 repeating. And now we have a little bit of confusion, but not much. I'm just going to, I should have done this on top again. Let's see if I can move it. There we go. Now I'm going to do my subtracting again, and let's see what happens. 100x minus x is 99x. 16 minus 0 is 16. Good so far. Point. Well, we have numbers that look like this. If I'm just worrying about the decimal portions, I have 0.666 onward minus 0.1666 onwards. And all these 6's are going to cancel. So what I'm left with is just 0.6 minus 0.1. Well, what's 0.6 minus 0.1? It's just 0.5. 6.6 minus 0.1 is 0.5. So now we have no more infinite part. So let's see what happens. I'll divide both sides by 99, and I'll get x equals 16.5 over 99. And now this one's a little rough looking. How can I fix this? Well, I don't like to have decimals in my fractions. So I'm actually going to multiply by 2 first. Times 2 times 2. This takes some manipulating sometimes. And on the top, I'm going to get 33, it looks like. On the bottom, I'm going to have 99 times 2. I'm not even going to multiply it out. Not even going to multiply out 99 times 2. Because you might see here that I have something happening. I have 33 over 99. What's 33 over 99? This can cancel. We can divide by 11 and get 9/3. We can divide by 33 and get 1/3. So this is equal to 1 over 3 times 2, or 1 over 6. So that was a slightly more challenging one, but we still arrived at the correct answer. Moving forward, what if you have something that's very repeating? I don't even know what 0.12 repeating is, but let's try to figure it out. We have something that repeats a whole lot. So this would be 0.12, 12, 12, 12, always going back and forth. And let's see if we can find a fraction representation of it by using our new rule. My first step is just setting x equal to 0.12 repeating. Now I'll multiply by, well, I have 2 repeating pieces, or I have 2 significant numbers here. Since I have 2 of them, I'm going to have to multiply by 100, or one with 2 zeros after it. And everything looks pretty. In fact, it looks prettier than the last problem. So let's do our subtracting. We will get 99x equals just a 12. Perfect. Divide by 99. X equals 12 over 99, which is equal to, I see these are both divisible by 3. I can add their digits, and on the top I get 1 plus 2 is 3, which is divisible by 3, and on the bottom 9 plus 9 is 18, which is divisible by 3. So I'll divide them both by 3, and I get 4 over 33. So something as confusing as 0.12 repeating, we can say with certainty is equal to 4 over 33 with our new method. And you see that there's not that much work. Sometimes there's a little bit of manipulating, but most of the time you're just simplifying fractions.